Okay, so we've got a question here, and it's about a shape in 3D, and it's telling us that it's made of a cylinder and a hemisphere, and it's telling us the radius of the cylinder is equal to the radius of the hemisphere. The cylinder has a height, and it's got a surface area. Okay, so there's the clue. This is about surface area, and it's about a hemisphere, and it wants you to work out the total surface area in terms of pi. Okay, so at the front of your exam paper, if you don't remember formulas, some of them are there, not all of them, but some of them. And a hemisphere is half a sphere. So when we look at this, it tells us the surface area of the sphere is 4 pi r squared. So a hemisphere would be half of that, so 2 pi r squared. So our starting point for this question would be that we don't know the radius. So it would be really nice for the cylinder bit if we knew the radius. Again, how do we know that? Well, ideally when we get questions involving formulas, we should write them down. So the hemisphere we said was 2 pi r squared. So this is the surface area, and that came from the sphere being 4 pi r squared, and then we halve that for a hemisphere. And then for a cylinder, because it wants the total surface area, then for a cylinder we've got to remember that the net of a cylinder, so if you imagine the net of the cylinder is like that, but we won't need the top circle because that's part of the hemisphere, and so therefore we can ignore that bit. But basically the surface area then is going to be this rectangle. Well, if we remember, this folds round the circle, so the width of the rectangle is pi d, and the length of the rectangle is L, and this is a circle, and a circle has an area of pi r squared. So for the cylinder then, we have pi d plus pi r squared for the surface area. So basically we need r. We can't do the question without finding the value of r. So we need some information in here which will help us do that. Well, they've given us a value here. They've told us that the surface area of the hemisphere is 32 pi square centimetres. We know the surface area of a hemisphere is 2 pi r squared. Okay, we're not interested in the circle at the bottom there because that's enclosed. The surface area is literally the outside bit, so it's like half the sphere's surface area. So we can start off by saying that 2 pi r squared is equal to 32 pi. That's true, that's the same as that. So we want r, so we're going to make r the subject by dividing by pi first. In fact, I'll divide by 2 pi because I've got 2 pi there, and I know that 2 will go in there and that, so I'll divide by 2 pi first. So that gives me r squared is equal to 16. Now we've got to remember, guys, it's 32 pi divided by 2 pi. Pi divided by pi is 1, so they cancel down to 1. And 32 divided by that is 16. So 32 divided by 2 is 16. So we know that r squared is the same as 16, so r must be worth 4. Square root of 16, so we square root both sides, and we get r is 4. So now we know that r is 4, then we go back to what we wrote down as the formula for the surface area of the cylinder. So for the cylinder, so the cylinder's surface area is going to equal pi d plus pi r squared. Well, we've decided the radius is 4 centimetres. Now they told us that the cylinder and the hemisphere both have the same radius, which is pretty logical from the drawing. They've both got the same radius. So we knew from the information that this r was going to be useful. So pi times 8, because diameter is 2r. Got to remember that the diameter is equal to 2r, d being the diameter, and the diameter being all the way across the centre, and the radius being from the centre to the outside. So the diameter is twice the radius, so pi times 8 plus, and pi times 4 squared. Well, that gives me 8 pi, that gives me 16 pi. So in total then, that's going to be 8 plus 16, which makes 24 pi. Okay, Now, when I look at this, I'm thinking I've missed something out here because we need the length of the cylinder. Now, if I go back to the net, then I can see that the area of this was pi dl. So in this formula for the surface area of the cylinder, I made the mistake of missing L out. So it's really important you check yourself. So pi dl, so pi dl. So I need to be times in by 10 here as well. So the formula for the surface area of the cylinder I wrote down wrongly to start with, but I've checked myself, and pi dl is the surface area of the curved surface, and plus pi r squared. So this should be 80 pi, and when I do 80 plus that I get 96 pi. Okay, so I've checked myself, that should be 80 pi, that should be 16 pi. When I add those together I get 96 pi, and that's for the cylinder. So the total surface area is going to be the 96 pi plus the 32 they originally gave us, and it was 32 pi. Remember, they're talking about pi's here because the question said in terms of pi, so that's really important, and that gives us a total of 128 pi. So on the dot dot line it's going to be 128 pi square centimetres. Okay, so very quick recap then. So it's talking about surface area of this shape. We recognise that the top is a hemisphere, which is half a sphere. The sphere had a surface area of 4 pi r squared, so we halve that to get the hemisphere's surface area. We need the surface area of the cylinder as well because the question asks for the total surface area. Net of the cylinder showed us that the area of the curved surface on a cylinder is pi d times L, so you've got to remember it's pi dl, and then the area of the circle, because we only need one circle for the bottom, and that was then plus pi r squared for the area of the circle. So that told us then we need r before we can get any of this information sorted to get the total surface area. But we had a fact given to us, so we made the surface area of the hemisphere equal to that fact, and then we rearranged this to get r, and we found that the radius of this shape was 4 centimetres. Worked out the surface area of the cylinder, being careful to write the correct formula, pi dl plus pi r squared. If it was a full cylinder, then it would be pi dl plus 2 pi r squared, but we only had one circle to deal with for this one. So worked out that, got the surface area in terms of pi, and then we worked out the total surface area. So that's an example of doing surface area with a 3D shape.